Welcome to this tutorial, guys. This tutorial is on trigonometric functions, and essentially we're going through sine, cos, and tan graphs in some detail, and then we're going to show how they relate to cosec, cos, and cot. Okay, so learning about sine, cos, and tan without actually seeing what they look like, seeing what the graphs look like, is pretty much useless. And so I'm going to start off by just drawing what these graphs look like. Okay, they may look a bit funny initially, but they become very useful and we can see how they relate to each other. Okay, so the first graph I'm going to draw is sine theta. Okay, so I think most people are used to working in degrees at school, so we're going to work in degrees. Okay, so on the y-axis we go to a maximum, so the maximum amplitude is 1 and the minimum is -1. Okay, the most important points that we're concerned about is 90 degrees or 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So as you can see, there's a difference of 90 degrees. Okay, so what does the sine graph look like? Okay, so the sine graph starts at 0. Okay, it peaks at 90, hits 0 at 180, drops to its lowest point at 270, and goes to 360. Okay, and so the period of a sine graph is 360 degrees. Okay, and what the graph looks like is something like this. Okay, so I might not draw it nicely, but let's see if I can get the general shape of it. It's a nice curve, essentially. Okay, taking away the bumps and whatever. So it should be a curve. Okay, so let me actually try see if I can do that a little bit better. Okay, so it looks something like that. So it looks a bit better. Okay, now I'm just going to show what that relates to when we're working in radians. Okay, so it becomes useful to work in radians later, but I just want to show you what it looks like so that when you come to it later, you'll understand. Okay, so again, we're working at 0 degrees, pi over 2 degrees, pi degrees, 3 over 2 pi, and 2 pi. So when we're working in radians, the period is 2 pi. Okay, and then another thing to note is that all these graphs, sine, cos, tan, these graphs never end. So essentially, the graphs continue with their pattern. Okay, and so if you draw this backwards, it would be -90, -180, and the graph goes on. So it goes on forever. Okay, so that's what the sine graph looks like. So important to note that the sine graph starts at 0. Let's try to draw the cosine graph or the cos graph. So some people get confused, but cosine theta is equal to cos. So it's just an abbreviation. You just take off the cosine just so that it's easier. Okay, so again, it has a maximum value of, this graph isn't very well centered on the line, but let's just go, it's got a maximum value of 1, a minimum value of -1. Again, the points of interest is 90, 180, 270, and 360. Okay, and again, we're working in degrees. If we're working in radians, we have pi over 2, 3 over 2 pi, and 2 pi. That is for radians. Okay, so what does a cos graph look like? Okay, so the cos graph actually starts at 1, goes through the origin at 90, hits its minimum value at 180, goes through the origin again, or not the origin, but hits the x-axis at 270, and goes back to 1. So again, we can see it's got a period of 270 degrees. So what does the graph look like? Again, we have a smooth curve. So I know my curve isn't, oh, that was horrible. I know my graph isn't the most smooth graph, but I think you can get the point. Okay, looks something like that. And again, this graph doesn't end there. It continues forever, following the same pattern. So minus 90 minus 180. Okay, so it continues the pattern on this side and on this side. Okay, something interesting to note, right? This graph starts at 1, and if we look at the cos graph, it starts at 0. But let's work in a nice different color. If we take these two graphs, right, let's zoom out, they look very similar. It looks like if I had the sine graph starting at this point, so if I had the x-axis at, or the y-axis rather, at that point, it looks like we actually have the same graph. So they look pretty much the same. So that's something to note, that the sine and cos graph are actually related to each other by 90 degrees. Okay, and that becomes quite useful. Okay, so again, that's something to note. Okay, now let's draw the last graph, which is the tan graph. Okay, and all these graphs have important points of 0, 90, 180, 270, and 360. We're working in degrees. 0, pi, or pi over 2, pi, 3 over 2 pi, and 2 pi radians. Okay, so what does a tan graph look like? Okay, first of all, we know what an asymptote is, right? An asymptote is simply a point on a graph, or point that the graph cannot touch. So we have asymptotes. We have asymptotes at 90 and 270. So essentially our graphs cannot intersect that line at 90 or 270. Okay, and what does the graph look like? It looks something like this. Okay, it's a bit different to the sine and cos. Okay, but that's what the graphs look like. Okay, so this graph, as we can see here, it goes to infinity. So the uppermost point is infinity, and the lowermost point is negative infinity. So it goes all the way down forever and ever, and goes all the way up forever and ever. And just like the other graphs, the graph doesn't end there. It goes on with the same pattern, having asymptotes at 90-degree intervals. Okay, so at minus 90, we have another asymptote. Okay, and minus 180. So the graph goes on forever and ever. So it's quite important that you guys know what the graphs look like and that you're able to draw it. It'll just help when you're doing some of the work. Okay, so now let's get on to cosec, sec, and cot. Okay, so we know what sine theta looks like, we know what cos theta looks like, and we know what tan theta looks like. Okay, so essentially these are just definitions. So we can say that sine theta equals 1 over cosec theta. Cos theta equals 1 over sec theta. And tan theta equals 1 over cot theta. Okay, so that's just by definition. And obviously it holds that cosec theta equals 1 over sine theta, sec theta equals 1 over cos theta, and cot theta equals 1 over tan theta. Okay, so these graphs are quite strange and they look quite weird, and we don't really need to know how to draw them. If we did want to draw one of them, let's just draw this one. Essentially, the graph looks something like that. It's got, let me change colors. So cosec theta looks something like that, with asymptotes there. Okay, so it essentially just hits at the peaks. But again, you don't need to know how to draw these. It's just important to know how they are defined, and we often use them in calculations. Yeah, okay, so the way I remember it, sometimes it's hard to remember. How I try to remember it is that cos and sec are related, so and tan and cot are related, and therefore sine has to be related by cosec. Yeah, but just find something that works for you so you're able to remember them, because they do come up often. Okay, in the next video, I'm going to discuss converting from radians to degrees and doing some examples. Okay, thanks for watching, guys.